Welcome to the video lecture in digital electronics. In this video lecture, we are going to discuss about how to perform subtraction using r-1's complements. So, the r-1's complement of a number system is also known as diminished radix complement. The r-1's complement is also known as diminished radix complements, right? So if you want to perform the subtraction using r-1's complement, the value of r-1 changes with respect to the number system. So for binary number system, that is, if you want to perform the subtraction between two binary numbers, the r-1's complement is nothing but 1's complement. So that is nothing but 1's complement. That means we have to use the 1's complements in subtraction of two binary numbers. So if we want to perform the subtraction between two decimal numbers, the r-1's complement is nothing but 9's complement. So based on the number system, right, or based on the numbers, either you can use the 1's complement if the numbers are of binary, or you can use the 9's complement if the number is of decimal numbers, right? So let us see what are the steps that are involved in the subtraction operation by using r-1's complement system. To perform subtraction between two numbers, say m and n, to perform subtraction between m and n, that is nothing but m minus n, the following steps are followed. So the first one is to add the minuend m to the r-1's complement of subtrahend n. r-1's complement of n, right? So if you want to perform subtraction between two numbers m and n, where m is called the first number, or the m value is called minuend, where n is called subtrahend, right? So basically the subtrahend is the negative number, so that we calculate the complement of the subtrahend and add to the n. So m, that is nothing but add the minuend m, that is m plus r-1's complement of n. We already know how to find the r-1's complement. The formula is r power n minus 1 minus n. So add the minuend m to the r-1's complement of n. So in this case we need to find the complement for the negative number, and that complement value is added to the first number, that is minuend. So that's the first step. So in the second step, so if the two numbers, if my m is greater than n, so if in my two numbers m and n, if my m is greater than n, the sum produces a carry. So I will define what is a carry after this point. So if my m is greater than n, the sum produces a carry, right? So add carry to this sum. So if we have the carry, that carry is again added to this sum. So this is called end around carry. right? So if there is a carry, that carry is to be added to the sum. So adding the carry to the sum is called AND around carry. The procedure is called AND around carry. So if my m is greater than n, so there is a carry, do AND around carry. That means add the carry to the sum. So now let us see what is this carry, right? So if we want to add two numbers, assume two 1-bit numbers I am going to add, right? So the possible combinations are 0 plus 0. In this case the sum is 0, very straightforward. Or 0 plus 1, so in this case the sum is 1. Or a 1 plus 0, in this case also the sum is 1. So if I add 1 plus 1, so basically 1 plus 1 is a 2. 2 is represented in binary as 1 0. You can observe in the last case, if we try to add two 1-bit numbers and we assume the result is also to be 1 bit, that is possible in first three combinations. You can see I tried to add two 1-bit numbers and I obtain the result is also 1 bit. Except in the fourth combination, sometimes the result may exceeds more than 1 bit. So that extra bit is called carry. So this extra bit is called carry, right? So in the second point we are saying if my m is greater than n, the sum produces a carry. So that carry is again added to the sum, and that's what we result. Third point is if my m less than n, that means we are trying to subtract a larger number from a smaller number. If my m is less than n, the sum does not produce any carry. The sum does not produce any carry. That too, the result is in complement form. We already know if we try to subtract a larger digit from a smaller digit, the result is negative, right? So in digital electronics, the negative result is stored in complement notation. That's what happens in this third point. So if my m less than n, the sum does not produce any carry and the result is also in complemented form. So the sum does not produce any carry, the result is in complemented form. The result is in complemented form. So to obtain the result in familiar form, to obtain the result in normal form, we have to find the r minus 1's complement of the sum and add a minus sign in front of it. That is, to obtain the result in normal form, what we have to do is find the r minus 1's complement. That is nothing but 1's complement if you are doing the subtraction with the binary numbers. That is 9's complement if you are doing subtraction with the decimal numbers, right? So whatever the number system is, find the r minus 1's complement of the sum, r minus 1's complement of sum, and add a minus sign in front of it, because we do understand the negative result by looking into the sign, right? So for this reason only we are adding a minus sign in front of it, so that we came to know that the result is a negative. So this is what the three steps followed while performing the subtraction operation using r minus 1's complement. So once again I am repeating the r minus 1's complement. So the value of r minus 1 changes with respect to the number system we used. That is, if you want to perform the subtraction between two binary numbers, the r minus 1's complement is nothing but 1's complements. If you are so if you want to perform subtraction between two decimal numbers, the r minus 1's complement is nothing but 9's complement. So based on the numbers, the r minus 1's complement may be a 1's complement or a 9's complement. So these are the three procedures, three steps we followed. First of all, we find the r minus 1's complement of the negative number and it is added to the first number. So if there is a carry, so in case when the carry is generated means if my m is greater than n, there is a carry. So the carry is again added to the sum. So adding this carry again to the sum is called end around carry. So if my m is less than n, so the sum does not produce any carry and the result is also in complemented form. So to obtain the result in normal form, find the r minus 1's complement of the sum, right, and add a minus sign in front of it. Now it is a familiar form for us, right? So let us see with an example by taking two binary numbers and by taking two decimal numbers how this procedure is executed step by step. Let us see one example, example 1. So we want to perform the subtraction between two binary numbers because it is 1011 and 0101. So it's a binary number. So if you want to perform the subtraction between these two binary numbers using 1's complements, right? So r minus 1's complement is nothing but 1's complement for binary number system. Right? So let us see. The first one here, in the given two numbers, my capital M value equal to the first number, that is 1011, and my n equal to, that is nothing but my negative number, n equal to 0101. So 1011 is nothing but 11 in decimal, right? So 0101 is nothing but 5 in decimal. So if you want to perform the subtraction between these two numbers, 11 minus 5, I want to get my answer to be 6, that is nothing but 0110, right? So let us see we are getting the actual result or not, right? So we identified the value of m and n. So ultimately we want to perform m minus n, that is equal to the first step, add the minuend m to the r minus 1's complement of n. So here the m minus n is equal to m plus 1's complement, m plus 1's complement of n, because for binary numbers the r minus 1's complement is 1's complement, right? So here my m value is 1011 minus n value is 0101, so which is equal to my m value, that is nothing but 011 plus 1's complement of 0101, 1's complement of 0101, so which is equal to 1011, that is my m, plus, so now we have to calculate the 1's complement of the n. We already know how to find the 1's complement of an n. We can find the 1's complement of a binary number by changing zeros into ones and ones into zeros. This is how we will find the 1's complement of a binary number. Simply invert. So simply change the zeros into ones and ones into zeros. So if we do so, so the 1's complement of 0101 is 1010. Now we have to add these two. So this can be done by writing one after another. That is 1011 is my m, and the 1's complement of n is 1010. Now we will go for the addition. So for the addition there is a very simple rules. So first 0 plus 0 is the 0, 0 plus 1 is the 1, 1 plus 0 is the 1. 1 plus 1 is the sum 0, carry 1. So the carry is propagated to the next higher order digit. So let us say first two LSB digits. 0, so 1 plus 0, it is 1. 1 plus 1, 1 0. So carry is propagated to the next higher order 1 and my sum is 0. Now we add 1 plus 0 plus 0, that is equal to 1. Again last two digits 1 plus 1 is equal to 1 0, that is 1 0. In this case we have the carry. So this bit is known as a carry. Why? Because we added two 4-bit numbers and we assume the result is also 4-bit, but in this case the result is 5 bits. So the fifth bit is called carry. So when do we obtain carry? Since we have to specify the reason behind why the carry is occurring, right? So I will write here, since there is a carry, since there is a carry, so that my m is greater than n, right? So if we have a carry, the meaning is that m greater than n. If we have no carry, the meaning is that m less than n. So what we have to do if there is a carry, make end around carry. Make end around carry. That is, add the carry to the sum again. That means this carry is added to the sum again. Now see, 1 plus 1 is again 1, 0, 1, as usual 1 and 0. So this is nothing but 6. That's what we need to obtain the actual result, 0, 1, 1, 0. Very simple. We have the carry. So since there is a carry, we have to specify whether the m greater than n or m less than n. Since there is a carry, m greater than n. If there is a carry generated, what we have to do? We have to do end around carry. So the end around carry is nothing but adding the carry to the sum again is called as end around carry, right? So this is how we will perform the subtraction by using ones complement for binary numbers. So in this case we consider the m value is greater than n. So we will discuss one more example where the n value is greater than m. So that is nothing but how to perform the subtraction of a larger number from a smaller number. This is the second case. So let us see one more example for that. So let us see one example, that is example 2. Perform subtraction between 0101, that is nothing but 5 in decimal, right? From that 5 we need to subtract 1010, that is nothing but 10. So here we are trying to subtract a larger digit from a smaller digit. So basically both are binary numbers. So because the base is 2, and for binary numbers we have to use ones complement. So let us see how to follow this one. So first we need to identify the value of m. So here the value of m equal to 0101 and the value of n equal to 1010. So I have to do m minus n, which is equal to m plus my ones complement of n. That is nothing but m minus n is nothing but m plus ones complement of n, which is equal to my m value is 0101 plus the ones complement of n. My n value is 1010. So which is nothing but 0101 is the actual m value plus now I have to calculate the ones complement of 1010. So it is very simple. Invert the digits, that is change the zeros into ones and ones into zeros. So 1010, so its ones complement is 0101. Now add these two. So let us add by writing one after another. So my first number is 0101. My second number is also 0101. Now perform the addition. 1 plus 1. So again 1 plus 1 is a 2. 2 is represented in binary as 1 0. So that 1 is known as a carry. 1 plus 1, 1 0. The carry is propagated to the next higher order digit. So again, now we have to add 3 digits, that is 1 plus 0 plus 0, that is nothing but 1. Again 1 plus 1, so 1 0. So 1 plus 0 plus 0, that is 1. So in this case you can observe there is no carry, right? So since there is no carry, since there is no carry, m is less than n. So you can see there is no carry. So how we are saying there is no carry? Because we took two numbers of 4 bits each and the result is also 4 bit. We obtained the result is also same 4 bit. There is no extra bit. So there is no fifth bit. So there is no carry. So since there is a no carry, what I can say is, so my m value is less than n. So this is the final result, but it is in complemented form. So what we have to do is to find the result in a familiar form. So find the r minus 1's complement. That is nothing but 1's complement of the sum and add a minus sign of it. That is nothing but my result equal to find the 1's complement of the sum. That is nothing but 1's complement of my sum. My sum is 1 0 1 0. Find the 1's complement of the sum and add a minus sign in front of it. That is what my result. So which is equal to minus the 1's complement of 1 0 1 0, that is nothing but 0 1 0 1, which is nothing but 5. So in this case it is equal to minus 5. You can see 5 minus 10, result is a minus 5. So minus 0 1 0 1. So this is how we will perform the subtraction between two numbers where the number being subtracted is the largest one, or the subtrahend is the largest one. So in a similar manner we will perform the subtraction between two decimal numbers by using 9's complement. Let us see one more example of that. So let us see example 3. So in this third example, we considered two decimal numbers and we can use the 9's complement, because for a decimal number system, the r minus 1's complement is 10 minus 1, that is nothing but 9's complement. So let us see how to find this, right? So here the first number is 780 and the second number is 210. Surely the answer would be, that is 7 minus 2 5, 8 minus 1 7 0. The 570 is what I have to get. This is my final result, right? So let us, we know directly we can subtract, because we already know how to perform subtraction, but in this subtraction we are using complements. That means we do the addition operation but we will get the subtraction result, right? So let us see how this can be done. So first identify the value of m and n. So my m value is equal to 780 and my n value equal to 210. So I have to do m minus n, which is nothing but my m plus 9's complement of n, because it is a decimal number, right? So which is equal to my m value is 780 plus my 9's complement of 210, right? So which is equal to my 780 plus, now we have to find the 9's complement of the number. So how do we find the 9's complement of a number? Simply subtract each digit from 9. Subtract each digit from 9. So that what gives you the 9's complement of a number. So let us see the 9's complement of 210. Subtract each digit from 9. So the most significant digit, that is 2. 9 minus 2, that is 7. 9 minus 1, that is 8. 9 minus 0, that is 9. So 7, 8, 9 is the nines complement of the 210. Subtract each digit from 9. So let us add these two digits. First digit is 780, next digit is 789. Let us add these two. 0 plus 9 is a 9, 8 plus 8 is a 16. So in that 16, 1 is the carry, 6 is the sum, 16. Again, 1 plus 7 plus 7, that is 15, 1 and 5. So this extra 1 is called carry, because we added two decimal numbers, each one is of 3 digit. You can see 780 is a 3 digit number, 789 it is also a 3 digit number, and we expect the result is also 3 digit, but the result is a 4 digit, 1569. So the extra digit or the digit in the left hand side is called the carry, right? So when we have a carry, since there is a carry, since there is a carry, means my m is greater than n. So surely it is known that 780 is greater than 210, so that we are having the carry. So what we have to do to this carry? Make end around carry. So end around carry is nothing but adding your carry back to your sum. So let us see. 9 plus 1, 10. So in that 10, 1 is the carry, 0 is the sum. So 6 plus 1, 7 and 5 as it is. There is no 1. The 1 is added to this sum. So 570. So 570 is our result. So what we have to get? 570. So the same problem can be done by changing the value of m and n. You can consider the value of m is 210, and you can consider the value of n is 780. So in this case also you will get the same 780, but at the end you have to get minus 780. Right? So we have the result, we have the sum, but that is in complement form. By finding the nines complement again, you will get the negative result. You can practice it. You can just change the value of m and n, interchange the value of m and n, and see whether you are getting minus 570 or not. So this is how you will perform the subtraction operation by using r minus 1's complement. So in a similar manner, you can find the subtraction, or you can perform the subtraction by using r's complement as well. So the r's complement is nothing but 2's complement for binary number system and 10's complement for decimal number system. Same, whatever the procedures we follow, they have these different set of steps, and by following those you can find the subtraction by using r's complement as well. So that means you can perform the subtraction by using any one of the complement, either by using r's complement or by using r minus 1's complement. So in the next video lecture, we will describe how to find this, how to perform the subtraction by using r's complement. That's all for today. Thank you.